Hello everyone! Here we will discuss about evaporation, boiling, and difference between them. Evaporation is the process in which the molecules at the surface of a liquid gain sufficient energy to overcome the attractive intermolecular forces and escape into the surrounding in the form of gas. Evaporation can occur at any temperature as long as substance is in liquid form. During evaporation, when the molecules escape from the liquid, they also take out thermal energy. Thus, the rest of the molecules in liquid form remains relatively cooler. In the diagram you can see more energetic molecules that escape carry thermal energy away from the rest of the volume. There are some molecules that rebound into the liquid due to collisions with air molecules, which is also known as Brownian motion. Also, evaporation occurs only at the surface of the liquid and with less energetic molecules, which means molecules having a lower temperature are left behind in the liquid form. One similarity between evaporation and boiling is that in both the processes, liquid gets converted into gas. However, the difference is boiling occurs at a specific temperature, which is known as the boiling point, and evaporation occurs at all temperatures including the boiling point as long as the substance is in liquid form. Boiling is a quick process as it has a higher thermal energy, so it occurs throughout the volume of the liquid. And evaporation, as we know, only occurs at the surface of the liquid, that is in contact with surroundings. In boiling process, substance absorbs heat from the source, and in evaporation, substance loses thermal energy to the atmosphere or surroundings. As we know, in evaporation, highly energetic particles are converted into the gaseous form and leaves the surface of liquid. Heat usually flows from a higher temperature to a lower temperature to maintain the thermal equilibrium. Evaporation has applications in our day-to-day lives. As we have seen, when we exercise a lot, we sweat because due to exercise, our body temperature increases and we sweat in the form of liquid. This liquid absorbs the body heat and gets converted into vapor, taking the heat away from our skin, resulting in the sensation of coolness. There are few factors affecting the rate of evaporation. First is temperature, as we know that the rate of evaporation is related to the internal energy of matter, and internal energy of molecules increases as the temperature increases. So when the temperature in surroundings is higher, the rate of evaporation is also higher. The warmer the surroundings are, the more heat is supplied to the liquid, and then it is absorbed by the liquid, resulting in faster rate of evaporation. The boiling point of liquid also affects the rate of evaporation of that liquid, as liquids with a lower boiling points evaporate faster than those with higher boiling points. Now consider water, which has the boiling point of 100 degrees Celsius and boiling point of mercury, which is 350 degrees Celsius. Both materials are in liquid form at room temperature. The boiling point of water is much lesser than mercury, so water kept at room temperature will evaporate faster than mercury. Another factor is exposed surface area of the liquid. A larger exposed surface area means more space is available for particles to escape. Thus, the greater exposed surface area will increase the rate of evaporation. One of the most common examples of the exposed surface area is the tea kept in a saucer and in a cup. Now we know that the saucer has a much higher surface area than the cup. This is why the tea poured in the saucer cools down much faster than the tea held in a cup. Humidity of surrounding air also affects the rate of evaporation, as rate of evaporation depends on how much liquid surroundings can hold. The humidity of surrounding air is high, the rate of evaporation is low. When the humidity is high, the concentration of water vapor present in the air is high. This slows down the rate of evaporation. One of the best examples is that on rainy days, it is difficult to dry our clothes due to the excessive humidity in air. The surrounding air pressure also affects the rate of evaporation. As air molecules exert pressure on the surface of the liquid, the higher pressure reduces the rate of evaporation. Due to heavy pressure, molecules require higher internal energy to exit. The last point is the movement of air on the surface of the liquid. Whenever evaporation takes place, the water vapor usually remains just above the surface of liquid. This water vapor blocks the movement of other molecules in liquid, and thus reduces the rate of evaporation. However, blowing wind on the surface of the water helps get rid of that water vapor on the surface, allowing a faster rate of evaporation. One of the good examples for this is how we blow air on the hot tea to cool it faster.